Welcome to EDU World Space.
Let's do this chemistry problem, and before I start, I recommend students to pause the video, do the question themselves, and come back to see if they got it right or not. That is a true way of knowing if you fully understand the topic. So, we have part A, where we want to find the mass of sucrose, which is C12H22O11, right? And we are given the mole, so it is 0.105 mole, and we can easily use the formula mass equals mole times mR. And we have the mole, and we can easily find the mR using the periodic table, right? So that's what I did. It should be mass equals 0.105 times the mR, which I calculated using the periodic table, and it was 342.30. All you can do is just find the atomic mass of carbon times it by 12, hydrogen times it by 22, and oxygen times 11, and just add them together, and you should get 342.30. So anyway, using a calculator, you should get the mass of sucrose to be 35.915 grams. And using the right significant figures, you can get... So that should be the answer for part A. Now moving on to part B. We want to find the moles of zinc nitrate in 143.5 grams. So we are given, that's zinc nitrate, right? And we're given the mass, which is 143.5 grams. And we want to find the moles. So we can easily use the formula moles equals mass divided by mR. We already have the mass. We can figure out the mR from the periodic table, and it should be 143.5 grams over mR. I calculated using the periodic table, and it was 189.36. And if you notice, the grams cancel and show the root of mole, which is 0.7578 mole. Now moving on to the next part. We want to find for part C, we want to find the number of molecules, right? And we're given the mole, which is 1 times 10 to the power of minus 6 of CH3CH2OH, right? And whenever a question asks for molecules, just think of Avogadro's number, right? It's very necessary here. If you multiply Avogadro's number with the moles, you should easily get the number of molecules. And in that case, it would be, using a calculator, I got 6.017, right? So that's the answer for part C. And finally, moving on to part D. So we want to find the number of nitrogen atoms, right, in 0. mole of ammonia, right? So what we can do is that we can use the mR of nitrogen and divide it by the mR of ammonia. So that would be 14.01 is the mR of nitrogen itself, and 17.031, which is the mR of ammonia, and then you can times that by the mole, right? And then you can times that by Avogadro's number, and you should get the number of nitrogen atoms. And I used my calculator and I got 2.0 times 10 to the, and I hope that was helpful.